Fine. So, what did we start with in the previous class? We had started with the basic concepts of mining frequent patterns. Hmm? Okay, so what was that frequent pattern mining all about? Hmm? In frequent pattern mining, what do we find out? What products are generally purchased together? Or what are the subsequent purchases after purchasing one particular product? For example, if the customer buys milk and bread, there are chances that she will also buy butter. So, what could be the subsequent purchase? Okay, so then I mentioned something about what is called market basket analysis. Okay, so that's an important concept which comes up in this association rule mining. Okay, so what was that market basket analysis all about? What was the example what I gave for it? For market basket analysis, can somebody recollect it? The example given for market basket analysis. No one remembers. Or
Ma'am,
nobody
the
want. Yeah.
diaper and beer.
Yeah. Diaper and beer was one example. I think I gave the familiar example of Big Basket. Big Basket, not Big Basket. What is it? Big Bazaar. Big Bazaar, where they keep chocolate chips and all the bakery items are being bundled together, assuming that the customers who buy biscuits will also buy chips. They will also buy chocolate. So with that assumption, so so it's more comfortable for the customers when they see all the items together. Okay, then this market basket analysis can be used to decide the perfect location where the items can be placed inside a store. Okay, that's why I gave the example of Big Bazaar. Then another example what I gave was McDonald's. So if you go to McDonald's, okay, so along with your burger, you would have come across what is called as combo offers. Combo offers at a very cheap price when compared to your individual purchases. Okay, so combo offers means your French fries or your wraps or your soft drinks and burgers coming all together in one pack as a combo offer. Okay, so this is under the assumption that people will find those things more attractive. So that's the reason why it's being given at a discounted rate. Okay, so these are all examples of what is called your market basket analysis. Okay, so um, then we'll just look into some of the fundamental concepts associated with association rule mining. The first one is what is called an item set. What is basically an item set? Hmm? What are all the set of items together in a particular transaction? For example, yeah, somebody said diaper and beer. So you can see this, there are five transactions out here: 10, 20, 30, 40, and 15. Transaction number 10. What are the items? Item set. So beer, nuts, and diaper form an item set. The second transaction, beer, coffee, and diaper form another item set. Okay, so yeah, when you say item set, it will have one or more items. This is having three items, this is having three items. So there is this last transaction is having five items. Okay, so that's what is a item set. Okay, now coming to what is a frequent item set. Okay, so an item set which will occur frequently is what is called a frequent item set. Okay, so frequent item set mining in data mining is basically a technique which will help you to identify what are the things which are being bought together. Okay, so for example, it can be bread and butter which is being bought together. Okay, or laptop and let's say mouse, or laptop and antivirus, okay, being bought together. Okay, so that could be labeled as a frequent item set. Okay, so that's regarding item set and frequent item set. What about support and confidence? Support and confidence, I had mentioned about two metrics. Metrics associated with your frequent pattern mining. One is called support, another one is called confidence. Okay, so what was that support all about? Hmm? So when you say a particular rule has got 5% support, so what does it mean? Hmm? What does it mean? Akshata Saha, what does it mean when I say, rule is having 5% support? Or can somebody say? Everybody are sleeping or nobody knows? When I say a particular rule is having 5% support, what does it mean? At least you tell that you don't know. Nobody knows. Hiten? Okay, so this is equal to myself wasting the time in asking you. Okay, so support means, somebody wants to tell, please. I heard somebody unmuting.
They appear in 5% of the transactions.
Yes, that's what. So, like 5% of the transactions in that particular database follow the particular rule. When you say 5% support, okay, so total of 5% of the transactions will be abiding to the rule. That's what you mean by support. Okay, support is actually a measure of interestingness. Okay, you can say it refers to the default popularity of a product. Okay, so it tells you about the usefulness of the product, or it will tell you about the certainty of that particular rule. What we are telling about. Okay, so how do you find the support? I think we had looked into the equation for it. Yeah, support. You can see here frequency of a comma b divided by the total number of transactions. Okay, so yeah, frequency of a comma b together divided by the total number of transactions, that will give you the support count. Support of a implies b. Probability of a union b. Okay, so then another one is what is called your confidence. What is confidence? Confidence. So when I say 60% confidence, okay, so when I say 60% confidence, it means that 60% of the customers who have purchased milk as well as bread has also bought butter. Okay, so then I can say it happens with 60% confidence. Okay, so you can say that it's the possibility that the customers are buying both the items together. For example, it can be biscuit and chocolates together. I can say with confidence that 60% confidence that the customers are buying both biscuits and chocolates together. Or the people who have purchased milk and bread, they have also made a subsequent purchase of butter. So I can say that with 60% confidence. Okay, so the formula for confidence. So you can see here the support count of A union B divided by the support count of A. I think we had worked out a problem also. Okay, so if a rule is satisfying both the minimum support count and the minimum confidence, then you can call it as a strong rule. Okay, so what do you mean by the support count? Support count, I kept on telling the support count. What is that support count all about? Okay, so the number of transactions in which X appears. Okay, so for example, if X is A union B, then it will be the number of transactions in which A and B both are present. Okay, so that's what you mean by a support count. Okay, so like a set of items in a particular, that is nothing but an item set. So you call it as frequent if it satisfies the minimum threshold value for your support and confidence. Okay, so support shows the transactions with items purchased together as a single transaction. Okay, so confidence will show the transactions where the items are purchased one after the other. Milk and butter after that, say a third one. Okay, so for frequent item set mining method, we consider only those transactions which meets that minimum support threshold and confidence requirements. Okay, then you have one more thing called closed item set. We saw item set. What is a frequent item set? Frequent item set. Then we saw two metrics, support and confidence. I think we had worked out a small problem also with that. This one, see, there are 5 transactions. The occurrence of each is being given here, and we had calculated the support and confidence 3 by 5 and 4 by 3 by 4. Okay, so how do you get this 3? How do you get this 3? A occurs. How do you get this 3 here? Can somebody tell? 3 by 5. 5 is the total number of transactions. So what is this 3 stands for? Come on, somebody. What does the 3 stands for? How do you get this 3 in this support, 3 by 5? Nobody understands anything in this class, huh?
A and D occur 3 times.
Yeah, A and D occurs 3 times. Okay, that occurs once here, twice, second time here, third time here. That's why 3 by 5. Okay, so this is, yeah, that's a 3 mentioned in the numerator. Then, yeah, 3 divided by the total number of transactions in which A is there. A is there in 4 transactions. That's why 3 out of 4, you get a confidence. Okay, so then the last concept is what we mean by closed item set. Just like you have your frequent item set, you have something called closed item set. Okay. So you can see here a closed item set. Okay. So if none of its immediate superset have the same support count as the item set. Okay. So when you have two items, let's say X and Y. Okay. So if each item of X is there in Y, but then there is at least one item in Y which is not in X, then Y is not a proper subset of superset of X. Okay, so in such case, you can say the item set is closed. Okay, so if X is a closed and frequent, then it is called closed frequent item set. Okay, so in simple words, I can say that a frequent closed item set means a frequent item set that is not included in a proper superset having the same support. Okay, so the set of frequent item sets, whatever we have discussed so far, so that will always be a subset of the frequent closed set. Okay, so the closed set will always be a subset of your frequent item set. Okay, and I mean, why are we discussing about this particular closed item set? Okay, because the closed item set, the count will always be much smaller when compared to your frequent item set. Okay, so and again, it is very easy to show that there is no information is being lost. Okay, because all the frequent item sets can be regenerated from the set of frequent closed item set because it is a subset of the frequent item set. Okay, so that's the last concept associated with it, closed item set. Okay, then we started discussing about last class we had started discussing about a priori algorithm. Okay, so I said frequent pattern mining, there are two categories to be considered, one with candidate generation and the second is without candidate generation. Okay, so in that the first category we had looked into what is nothing but the a priori algorithm. Okay, so and I mentioned that a priori algorithm is something which operates on database with a large number of transactions. Okay, so for example, I gave you that how I mean the items what customers buy at Big Bazaar. Okay, so I mean, this a priori algorithm will help the customers to buy their products a little more easy in an easy manner, and thereby the sales performance of the particular store can also be increased. Okay, so this we had discussed. Okay, so last class I had given an example for a priori algorithm, but then I had not discussed about the steps involved in it. Okay, I explained through the example. So now coming to the formal algorithmic steps involved in a priori algorithm. Okay, so what is the purpose of this a priori algorithm? After performing this a priori algorithm, what do you get? What is output of it? What is output of a priori algorithm? Frequent item sets, right? Frequent item sets, which are the frequent item sets in a particular database. When you are given a list of transactions, then in case you're given the minimum support and the confidence, then you can also find out which are the strong association rules among the various rules which are being generated. So that is the purpose of your a priori algorithm. Okay, so that's basically to find out the most frequent item set in a given database. Okay, so do you remember the example what was discussed for a priori algorithm? Yes or no? Do you remember the example what was discussed? this example. Okay, so we'll just refresh the example once again. So this a priori algorithm, I had told in the last class, you basically go for two sort of operations. One is what is called your join operation, and the second one is what is called your pruning operation. Okay, so these two steps are being iteratively performed till you get the most frequent item set. Okay, so basically a minimum support threshold will be given in the problem, or it will be generally suitably assumed by the user. So in our problem, I think we had given the minimum support count as 2. Okay, so first what you do is, in the first iteration, okay, in the first iteration, so each item is taken, and a one item set. Yeah, in the first iteration of the algorithm, each item is taken as a one item set candidate. Okay, so the algorithm will count the occurrence of each item. Okay, then that's what you did first. So you can see here. Okay, so each items are taken separately, as a one item set. Okay, and you write the support count for each, how many times each occurs in the transaction. So you can see here I1, how many times it occurs: 1, 2, 3, 4, 5, 6. So 6 times. So compute the support count for each. So that was the first step. Okay, then what is the next step? Then it will be given in the problem that there is some minimum support. Minimum support for, I think here it is given as 2. Okay, so the set of one item set whose occurrence is satisfying the minimum support is determined. Okay, so only those candidates which count more than or equal to the minimum support is taken ahead for the next iteration, and the others are being pruned. Okay, so that is the next step. So you can see here. So in the previous case, I think everything is satisfying the minimum support count. So there is nothing to be pruned here. Okay, so everything proceeds to the next step. Okay, so then after that, what do? You come to the third step. So next, what you do is you generate two item set, frequent items, with minimum support is being discovered. Okay, so this is nothing but a join step. Okay, so two item set is generated by forming a group by combining two items with itself. Then those candidates are being pruned by using the minimum support threshold value. Okay, so then the table will have only the two item set with minimum support only. Okay, so that's what you did next. See, two item set, and then the respective support count. So from here, there are items which do not satisfy the minimum support threshold. Okay, for example, one is this item, another one is these. So this can be eliminated. Okay, so all the three don't satisfy the minimum support count. Okay, so based on that, you get the, you sent the PPT moving. Just a second. Yeah, fine. So based on that, the last three transactions are being removed. Okay, so that's the next step. Okay, then again, similarly, you proceed. Okay, so in the next iteration, you form three item set. Then you join them and prune accordingly. Okay, then four item set. The same procedure. Okay, so when does this algorithm stop? Is it stops when the most frequent item set is achieved. Okay, so as per our example, you can see here, we come to step 3. We come to step 3, three item set with support counts 2 and 2 respectively, which satisfies the minimum support count. Okay, then if we proceed further, you will not get any frequent item set. Okay, so there is no item set in C4. Okay, so that's what we stop here because no frequent item sets are further found. Okay, so that's how we proceed with the a priori algorithm. Okay, so the algorithmic steps are being mentioned here in detail. So this is the two steps. Okay, how you find the frequent item set. You are basically performing a level wise search. Okay, so you start with the frequent one item set, then proceed to frequent 2 item set. So till all the maximum frequent item sets are searched. Okay, so these are the 2 steps which are being followed in a priori. The first one is what is called a join step. The second one is what is called a pruning step. Okay, so yeah. So join step means you're generating k plus 1 item sets from k items. Okay, that is by joining each item with itself. Okay, I gave you the example. Then the second one is pruning. Pruning means you scan the count of each item in the database. Okay, and if it's not meeting the minimum support, then that will be removed. Why it is removed? Because that is infrequent. Since it is infrequent, it will be removed. Okay, so there, that way you can reduce the size of the candidate item sets. Okay, so this is the flow chart for it. The same what I just explained. Generating the k item set, you check the support count, join and prune till you're able to find out all the frequent item sets. Okay, so this was the example which I had worked out in the previous class. So any doubts in this? Okay, so after generating the frequent item sets, okay, so now we can go, you can generate rules based on it. Okay, so then you can calculate the confidence for each rule. Okay, you can calculate the confidence for each rule and see which are the strong rules and which are the weak rules. Okay, so as per our example, we had considered a confidence of 60%. Okay, so let's see what are the rules which satisfies at 60% confidence. Okay. Yeah, no, 50% confidence. Yeah, as per the example, it is 50% confidence. So these are the 3 rules which satisfies the 50% confidence criteria. So they are considered to be strong association rules. Okay, so the remaining are considered to be weak association rules. Okay, so this was what we had discussed. Okay, now coming to the advantages and disadvantages. A priori algorithm is something which is very easy to understand. At the join and prune steps can also be implemented on large databases. But then there are many other algorithms like vertical span algorithm and closed span algorithms, SPADE and other things. So comparing to those algorithms, a priori algorithm is slow because you need to perform a number of database scanning and you need to scan all the transactions a number of times in order to come to the final output. Okay, so the overall performance can be reduced, gets reduced because you're scanning the database a number of times. Okay, so there are some techniques which if implemented, wherein you can improve the efficiency of your a priori algorithm. Okay, so now we'll look into what are those techniques. Okay, so that is how to reduce the number of passes in the transaction when you're scanning the database. So how to reduce the number of passes. Okay, because you are aware that when you say database scanning, it will involve accessing the disk, and that can be quite expensive. Okay, so in case you want to find 10 frequent item set, okay, so you will have to scan this database, say let's say 10 times. Okay, and that's something which is very expensive. Okay, so to reduce the number of scans, okay, so there are some techniques which are being proposed like partitioning method, then dynamic item set counting method. So these are the different techniques which are being proposed for improving the performance of your a priori algorithm. Okay, so we'll just have a brief look at the various techniques which are being proposed. So these are the computational challenges, ones which are shown in the PPT: multiple scans of transaction databases, huge number of candidates, and tedious workload of support counting for the candidates. So for improving the a priori, there are, 2 general techniques are being mentioned. One is to reduce the passes of the transaction database scan. This is one technique which is being proposed. Under this, we have 2 techniques. One is what is called partitioning technique, and the second one is what is called dynamic item set counting. Okay, so these are 2 techniques considered under reducing the passes of transaction database scan, and the second one is wherein you can shrink the number of candidates. That's the second major categorization. In that, you have three techniques. One is like creating what is something like a hash table. Then you can go for sampling, or you can even go for removing the ones which have some lower levels of confidence in other things. Some sort of pruning can be applied to shrink the number of candidates. Okay, it's not a very popular technique. Okay, so these are the two techniques. Okay, so then the third one is facilitate support counting of the candidates. Okay, so the first one is reducing the number of transaction database scan. Okay, so under that you have what is called a partitioning technique. Okay, so partitioning means what you're basically doing is, I mean, rather than scanning the database a number of times, I'll show you the diagram. Yeah, rather than scanning the database a number of times, you scan it only two times. Okay, you perform only two database scan in order to mine the frequent item set. You can see here phase 1 and phase 2 is mentioned here. Okay, so like it follows a thumb of rule that any item set to be potentially frequent in the database, it should be frequent in at least one of the partitions of the database. Okay, so the database is being partitioned into a number of partitions. So the assumption is like to call something as a potentially frequent item in the database, it should be frequent in at least one of the partitions. Okay, so that's what the partitioning technique tells you. Okay, so you dividing in it into a number of phases. Okay, sorry, number of partitions. So in the first scan, you scan the database only twice. So in the first scan, you partition the database and find the local frequent pattern. What is frequent with respect to that partition. Okay, similarly, you find the local frequent item in each of these partitions. Okay, so then after that, you can consolidate all those local frequent pattern, and then decide which is the uh, consolidate and decide which is the global frequent pattern. Okay, so that's what is partitioning all about. Okay, you combine all the local frequent item sets to form the global candidate item set. Okay, so basically you scan only twice. So therein you are reducing the number of transaction database scans. So this is what happens basically in mining, which is being performed by partitioning the data. Okay, so that's one technique. The second one is, you can see here, uh, dynamic item set counting. Okay, dynamic item set counting. So here, yeah, so what you're basically doing is you can add uh, new candidate item sets at any marked starting point. See, one starting point is there here and another starting point is there here. Okay, so during the scanning of the database, okay, so you need not go for everything. You can keep this as a starting point and start from here, or you can start from here. Okay, so you're dynamically marking the starting point. Okay, so once you find that once both A and D are determined to be frequent, then counting of AD begins. Okay, so once all the length two subsets of BCD are determined, in this case the counting of BCD determines. Okay, so you're reducing the number of scans by dynamically marking the starting point. Okay, so therein you can reduce the number of database scans. Okay, so this is a journal paper which speaks more about it. You can look into it. Those interested can look into it. Okay, so the next one is what is called a hash based technique. Okay, so wherein you are trying to you are hashing the items based on some hash function into some corresponding buckets. You can see here, these are the buckets. Okay, so it basically uses some hash function for generating the table. There are different hash functions available. Anyway, I'm not going to discuss those things. So you can see here a hash table H2 is created using some hashing function. Okay, so 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 this is all candidate 2 item set. Okay, so this hash table actually was generated by scanning the transactions whatever we used in the first example. We had around 6 transactions, T1, T2. So scanning that, this hash table is being computed. So let's say the minimum support count here is 3. Okay, so I'm just assuming, okay, giving minimum support is 3 here. Okay, so if I decide my threshold to be 3, so then whatever items are there in bucket 0, this bucket, then what else is there? This bucket, because I have only 2 items here. Okay, and even here, these 2 can be removed. Okay, so that's what. So if I say minimum support is 3, okay, then the items in bucket 0, 1, 3, 4, okay, so they can be removed. They will not be included in your candidate set 2. Why? Because they will be considered as infrequent. They cannot be frequent. Okay, so these sort of hashing techniques can also reduce the number of candidate k item sets, whatever is being examined. Okay, so out here this hash table is for 2 item set. Okay, so that's what the second technique is all about. Okay, so hashing the item sets into the corresponding buckets, then eliminating them based on their support count. Okay, so then the next one is what is called transaction reduction. Okay, so this is actually for reducing the number of transactions which are planned to be scanned in future. Okay, so yeah, so this method will reduce the number of transaction scanning in the iterations. So the transactions which do not contain the frequent items, so they will either be marked or removed. Okay, so that's what is transaction reduction all about. Next is withdrawing a sample from the population. Okay, sampling of frequent patterns. Okay, so that is when you say sample, it's nothing but a subset of the given data or given database. You're trying to mine on a subset of the given database. So you randomly one sample. This particular method will pick a random sample. Let's say, let's name it as S from the database D. Okay, and then it will search for the frequent item sets in that sample, which is considered to be a representative of the entire database. Okay, so there are chances that you lose the global frequent item set and other things. There are issues associated with sampling, but for the time being, just keep in mind sampling is one of the technique for reducing the number of transactions scanned. Okay, so of course you can even avoid that issue by reducing the or lowering your minimum support count and other things. There are techniques for it. So sampling for frequent patterns is nothing but mining on a subset of the given data. Okay, so like especially when you're using some computationally intensive applications which has to be run every now and then, okay, then it may be very difficult to look at the entire population and do an analysis for finding out the association, in which case you can draw a sample and then try to identify what is the frequent item from that particular sample. Okay, so that's regarding sampling. Okay, so that's the last technique in order to improve the efficiency of your a priori algorithm. Now coming to the applications. Okay, it can be used in n number of fields. Your education field, medical field, education field, what for it could be used? Can somebody tell me? Finding associations. So you can extract some sort of association rule uh, regarding the admitted students by looking at their characteristics or specialities or whatever. Then medical field for analyzing the patient database and other things, or by the forest departments. Okay, for analyzing the probability of or the forest fire, or in case a forest fire has occurred, to find the intensity. All those things can be used. Okay, these days your companies like Amazon and other companies like Google, they use frequent pattern mining in their recommendation systems. Even Google's autocomplete feature. All these are good applications of your a priori algorithm. Okay, so now I'll give you three. I have worked out one example. I want you to do another three problems, and before the class gets over, I want you to upload it in GCR. I've created a folder in GCR. There are three exercises. Note down the first one. Quickly note down the first one. So the minimum support is given as a 2 here. All the three should be uploaded as a single document. So I'll forward it to your WhatsApp group also. Or take a picture and put it in your group. Yeah, I have sent all the three problems to your class group. So by the time I take attendance, I want you to work it out, and all the three should be uploaded into your GCR at by 11:40, and 5 marks are there for it. So start doing it. So once I take attendance, I'll ask one of you to discuss the first problem. Hope all of you have made a note of it. Okay, now answer your
Yes.
attendance. Yeah, fine. So now answer your attendance. Has everyone got all the three problems?
Yes, ma'am.
Vishal? Okay, only Anirudh answers in this class. Huh? Where is your class representative here? Selva?
Yes, ma'am, I'm here, ma'am.
You are there. So what is your role as a class representative? Yesterday I wanted to schedule a class. You are not reachable, nothing. It's only Anirudh who speaks for the whole class. If that is the case, why don't Anirudh become the class representative rather than you?
Sorry, ma'am, I was traveling yesterday, ma'am.
You can put in a message, right?
Yes.
Okay, fine.
Sorry, ma'am, that was my fault. I was traveling yesterday. I just reached now in the early morning.
Okay, fine.
I couldn't able
Right.
to inform you. That's why.
Okay, answer your attendance, Anirudh.
Yes, ma'am.
Ram Harini, you can put it in the chat window and start working out the problem what I've given.
Ma'am, 3 present.
Yeah, noted. Dharini, okay. Ram Harini,
Present, ma'am.
Kalyan Sundar,
Present, ma'am.
Aravind,
Present.
Sharan Varghese.
Present, ma'am.
Started working the problem.
Yes, ma'am.
How far did you reach?
Not very far, ma'am.
Not very far means what? How far? Shakti Priya,
Present, ma'am.
Nishok,
Present, ma'am.
Shreya,
Present, ma'am.
Nikita,
Present, ma'am.
Suveda,
Present, ma'am.
Vishal Bhashyam.
Present, ma'am.
How far did you reach, Vishal?
Ma'am, I missed the question, ma'am. I wanted to note it.
You missed the question. I said
Yes,
I have
ma'am.
put it in the posted in the WhatsApp. Open the WhatsApp and check. It was not just in the PPT.
I didn't get, ma'am. I didn't get in WhatsApp.
Is it? Can somebody else confirm whether they've got in WhatsApp, class WhatsApp group?
Yes, ma'am. No, I have got it.
Please forward it to him.
Okay.
I'll be asking the first question with you, Vishal.
Okay, ma'am.
Srimati,
Present, ma'am.
Kamini, Nityashri,
Yes, ma'am.
Pranav.
Present, ma'am.
Finished first problem, Pranav.
Doing, ma'am.
Srimati, yes.
Present, ma'am.
Why no energy? Didn't have breakfast?
Yes, ma'am, I had.
Your voice sounds so feeble. Okay, Raja Singh,
Present, ma'am.
Pooja,
Yes, ma'am.
Lavanya,
Present, ma'am.
Nityashri,
Present, ma'am.
Sriram.
Chat box, ma'am.
Okay. Satyamohan,
Present, ma'am.
Sharan.
63 present, ma'am.
Okay. Okay, 63. Aviral Patel.
Present, ma'am.
Aviral, what are you doing?
Ma'am, doing, ma'am.
What are you doing?
What?
That's what. What are you doing right now?
Ma'am, I'm doing the question, ma'am.
That's what. How much did you progress is what I'm asking.
Actually, I'm at the first one, ma'am. I'm trying, ma'am. Trying to solve it.
What wonderful answers I get from this class. Hemavartini,
Present, ma'am.
Ajay,
Hey, present, ma'am.
Akshata Saha,
Present, ma'am.
Karthik Balaji.
Present, ma'am.
Okay, anybody has finished the first problem you put in the chat window? Let's see who has finished. Not the answer. Let's see who's a smart person who finishes first and start with the second problem. Santosh Kumar,
Yes, ma'am.
Anand Arun,
Present, ma'am.
Anand.
Present,
Okay. Rahul, okay, noted. Suhasini Srikanth,
Present, ma'am.
Apurva Ravichandran,
Present, ma'am.
Pithun,
Present, ma'am.
Adityan,
Present, ma'am.
Selva Niklesh,
Present, ma'am.
Ramcharan,
Present, ma'am.
Chinta Murari.
Present, ma'am.
Started with the second problem.
Ma'am, yes, ma'am, I'm trying.
I don't get a proper answer. Everybody keeps trying, but what you're trying, I'm not able to understand. Santosh Kumar,
Present, ma'am.
Pavitra Shri,
Yes, ma'am.
Praveen,
Present, ma'am.
Rakesh.
Present, ma'am.
How many scans did you do so far? Up to what step are you doing now? Don't give me the answer. You're trying and opening the book and all those things. At what point in the problem are you doing? Are you right now? Is what I'm asking.
I'm also just trying on it, ma'am.
Nityashri,
Present, ma'am.
Nishok. Okay, noted. Abel,
Present, ma'am.
Pritika, okay, Pritika, noted. Kevin Kurian Joseph. Kevin,
Present, ma'am.
okay. Hiten,
Present, ma'am.
Adya.
Present, ma'am.
Yes, heard. You have deafened my ears. Devora,
Yes, ma'am.
Kishore,
Present, ma'am.
Sridevi, okay. Yash Rai,
Yes, ma'am.
Jayesh Kumar,
Present, ma'am.
okay, right. So Rakesh, can you share the screen and share the solution for the first problem? It doesn't matter even if it goes wrong, but then I want you to share the screen, and otherwise I'm striking out your attendance. Rakesh. Rakesh, what happened? Okay, I'm striking out the attendance. So no response means no attendance. Absent. Okay, next person. Praveen, share the screen and share the solution for the first problem, or how much ever you have completed. Praveen, also no response. Okay, so marking you as absent. Wait. Registration number 12, Nishok. A section, Nishok.
From A section show here, ma'am.
Yes, Nishok. You are the person who joins half an hour before the class, no? Please.
No, ma'am. No, ma'am. Ma'am, I'm A section, ma'am.
Yeah, A section, Nishok. Please share the screen and share the answer. The first problem.
Ma'am, I'm not 12, ma'am. I'm 23, ma'am.
23, Nishok. You please share the screen and I'm talking to you only, Nishok. Registration number 23, A section. Okay, no response from both. I'm marking both as absent. Registration number 23, no attendance today. C section, Nishok, also no attendance today. Okay, so who has completed? No one has completed, huh? Can somebody respond? Or do you want me to show you the solution for the first problem? Pritika? Okay, I'm making a note of who all are leaving the meeting just because attendance is over. All those students, no attendance today. Anirudh has completed the first problem.
Ma'am, I'm doing from the third problem. I'm doing the third problem.
Third problem. Okay, go ahead with the third problem. Anybody has completed any of the problems out of 3? Wait, I'll show you a sample. Sample of the first solution. But then all the 3 should be uploaded as a single document in GCR. That's the assignment for you. Are you able to see the first one? This is the first one. Did anyone get egg, tea, and cold drink as the most frequented item set in this transaction basket? Or did anyone get more than one frequent item set?
Eggs and cold drink.
Eggs, tea, and cold drink. Did anyone get the same answer? What about the second problem? Second problem, I'm not going to show you the solution. Work it out on your own. It's a similar problem. Then the third one. Third one, I think the support count is given. What is the support count given? 50%, I think. 50% of support and 50% of confidence. So full 5 marks will be given for those who submit on time at 11:40. Any doubts? We have discussed the a priori algorithm, advantages, disadvantages, applications, and how to improve the efficiency by 5 different techniques. And we looked into the basic concepts. What were the basic concepts which we looked into today? What is basically an item set? What do you mean by a frequent item set? Then the 2 metrics associated with the association rule mining, that is support and confidence. Then what is support count? Then what is closed item set? Just like you have your frequent item set, you have something called closed item set. So these were the basic concepts discussed. Then how to calculate the support and confidence through an example. Then we discussed about a priori algorithm.
Ma'am, for the second one, is the answers egg and cold drink one?
Yeah, just a second. I'll clarify 1 second. Second example. Second is this one, right? Yeah.
Yes, ma'am.
Yes, very good. Who's that?
Sharon.
Very good, Sharon. Now start doing the third one. So only one person is doing. Only 2 people are doing.
Ma'am, is the third one A and C?
Third one. 1 second. Yes, very good. Who's that?
Nityashri, ma'am.
Nityashri. Very good, Nityashri. So don't share your answers with others. So I want all of you to work out all the 3. There are people who have done it very quickly. Very good. Hmm? So others, you upload your answers. So with that, I'm winding up. Thank you. So 23 Nishok, it will be